So EC experiments. The first experiment is clipper and clamping circuit. So for clipper and clamping circuit, we have three circuits. The first one is positive clipper. The second one is double-ended clipper. The other one is clamper circuit. So first we will do positive clipper circuits. For this circuit, required components. So required components is diode BY127, a resistor 10 kilo ohm, 3.3 kilo ohm, and DC power supply, and signal generator and CRO. So we will study what is diode. So this is a BY127. So this terminal is a negative terminal, and the other terminal, the flat one, is a positive terminal. So this is negative and this is a positive. So this is a diode. This is a negative terminal, the other one is positive terminal. So then a resistor. So we should keep like this. We should find it out what is the value of resistor. So this is a brown, black, then orange. So brown indicates 1. So we should go for color coding table. So the color coding table over here. So BB Rai goes Bangalore via Gateway. So brown is 1. So brown is 1. Then black is 0. Then orange. Orange is 3 into 10 to the power of 3. So 10 into 10 to the power of 3 equal to 10 kilo ohm. So this is how we need to calculate resistor value. then DC power supply. So this is the DC power supply which is having two sections. This is section 1 and section 2. So here in a section 1 we will get 0 to 30 volts. Here for here power supply also we are getting 0 to 30 volts. Variable power supply. Variable in the sense we can vary how much voltage we want by using knobs. So this is a positive terminal and this is a negative terminal. So in a variable power supply we are not going to use the green terminal over here. And here also this is a positive terminal and negative terminal. We are not going to use this one. So this is a voltage course, fine, and current knob always should be maximum. Current knob always should be maximum. Okay, this is regarding the power supply. And come to the CRO. So initially don't press any buttons. Don't press any buttons. So this is channel 1. This is channel 1 and this is channel 2. So preferably you go for using channel 1 for input and channel 2 for output. So this is to adjust the voltage level for the channel 1, and this is to adjust. If you want to increase the time period, you can just use this one, you can adjust. And we need to use only these two buttons. So if you leave this button, channel 1, if you press this button, channel 2. Okay, if you want to both the channel output, then press this button in a dual mode. Got it? So come to functional generator. So this is your functional generator. Again this is a coarse and fine, okay, to adjust the frequency. So when you leave this button, it shows, the display will shows the frequency. If you press this button, display will shows the voltage, and whatever the frequency you want, you can set it from these buttons. Okay, and adjust using coarse and fine frequency. If you want voltage, press this button and go to fine level and vary the voltage how much you require. So this is regarding your power functional generator. So we are going to take input signal from this terminal. Okay, and this is a springboard. So springboard, and there is having many springs here. So using this springboard, so just rig up the circuit. So this is a diode. We will just go for positive clipper diode. So negative of the terminal is connected to negative of the diode is connected to positive of the power supply. The circuit is like this. So this is a diode, this is a positive, and this is a negative. So negative is connected to DC power supply of positive terminal, and the negative terminal is connected to ground. So the negative terminal. The negative terminal of the power supply is connected to ground. Take this point as a common point. Understood? Then this one, a resistor 3.3 kilo ohm. The positive terminal of the diode is connected to one end of the resistor. So that is this is 3.3 kilo ohm resistor. The positive terminal of the diode is connected to one end of the resistor. The other end is connected to your signal generator. From here. So just this is a CRO probe which is having two terminals. Red is connected to your main terminal and black always is connected to common terminal. So this is your input terminal. So this is input terminal and the common terminal over here, because we have connected negative terminal to this point. Understood? So this is a input connection and the RL is there. So RL, the positive terminal of the diode is connected to one end of the resistor, 10 kilo ohm resistor. The positive terminal of the diode is here and connected to one end of the resistor. The other end is connected to ground. Somewhere else like this. Okay. And from across these two terminals, we need to connect CRO to check input signal, and these two terminals we need to connect again CRO to check the output signal. Okay. And this is the connection. And to check the input signal, again we need to connect where we have connected input signal. In the same point you just connect it, and the other point, the black terminal of the CRO probe is connected to common. Then use channel 2 for checking output signal. So output signal across load. So the positive terminal where you have connected, there you connect it. The other terminal is connected to common point, ground. Now switch on your power supply. So make sure that initially zero volts. Okay, keep it in minimum and see the CRO. So this is channel 1 and this is channel 2. So put it in. Now it is channel 1. So we can't see the signal. So use this section, adjust, so that you can see the output signal. Okay. So this is, so vertically 1 unit, 2 unit. 2 unit is taken, 2 into 5, 10 volts. We have given from the functional generator 10 volts. Okay. Then you want to see the output, you can put it in second. So even you cannot see the output because this is waveform is went off the screen. So use this one and adjust so that you will get a output waveform. So this is the output waveform. Now keep it in dual mode, and adjust press both the ground buttons, both the channel ground button, and use Y position and put it in the ground level. These two signals, keep it in ground level. Okay. Then open your ground level and output. So this is the output, always should be in a DC mode. So this is your output. Now check it out. This is your output. Check it out. So the sinusoidal waveform is input signal. The other one is clipped output waveform. So where it is clipped, just observe from 0 to the 1 subdivision. 1 subdivision is equal to 0.2. 0.2 into 5. 0.2 into 5. Okay. So with the V reference is 0 volts. For the 0 volts, you are getting clipped output voltage at the 0.7. So now adjust V reference voltage up to 1 volt. 1 volt. So now use level fine and adjust to 1 volt. Okay, 1 volts plus diode voltage is 0.7. 1 plus 0.7 is equal to 1.7 supposed to be get at the output. So check it out. So 1 subdivision, second subdivision. First subdivision is equal to 0.2. This is 0.4. 0.4 into 5, 2 volts. So 2 is approximately equal to 1.7. So there is a difference of 0.7. There is always difference between theoretical value and practical value. Okay, we can accept it. So this is a positive clipper, and you want to see the positive clipper, just put it in CRO XY mode and open this dual. So you will get in this fashion. So just interchange your CRO probe, interchange your CRO probe. Okay, now this is the output. Keep it in DC mode and this in AC mode. Now this is the transfer characteristics of your positive clipper. So here the clipping level, so approximately equal to 1.7. So DC reference voltage is 1 volt plus diode new voltage is 0.7. So sum of those two voltages is approximately equal to 1.7 volts. This is the transfer characteristics of positive clipper. So design for positive clipper. So V naught equal to VD plus V reference for positive waveform. So VD is always constant 0.7 voltage, because this is a new voltage for the diode, germanium diode, silicon diode, and V reference voltage is power supply. So V naught is equal to VD plus V reference. So VD is 0.7, V reference is 1 volts. So output voltage you will get 1.7 volts. Okay, and for this one calculation of resistor value, there is a relation. So 100 times RB less than RS less than 0.01 RL. So this condition is called strip clipper. So we will take this expression like this: RS less than 0.01 RL. So let RS is equal to 0.01 RL. Choose RL equal to 10 kilo ohm. So RS become 100 ohm. So here for a practical case we are going to choose 3.3 kilo ohm. RS is equal to 3.3 kilo ohm. Then RL is equal to 10 kilo ohm. Now the second experiment is double-ended clipper. So for this first we need to study design. So for positive waveform, V01 is equal to VD plus V reference 1. So V01 is a positive waveform, VD is always constant 0.7, V reference is a DC power supply. In the same way, for a negative side, V minus, negative side V02 equal to VD plus V reference 2. Okay. So suppose assume V reference is equal to 1 volts over here at the negative side 2 volts. So VD is 0.7 and here also VD is 0.7. So for at positive you will get output is equal to 1.7. At the negative waveform you should get 2.7 voltage. The circuit diagram for double-ended clipper. So input signal is 10 volts, frequency is 1 kilohertz from the functional generator, and this is RS series resistance. This is diode 1. Diode 1 is parallel with diode 2 with opposite polarity. So diode 1 positive is connected to one end of the RS, the negative terminal is connected to V reference 1 positive terminal, and the negative terminal of the V reference is connected to ground. And D2 diode, negative terminal of the diode is connected to one end of the RS where you have connected diode 1, and positive terminal of the D2 is connected to negative terminal of the power supply, the other section of power supply. The positive terminal of the V reference is connected to ground. Okay, the load is as usual, the where we have connected negative terminal of the diode 2 and positive terminal of the diode 1. From that point, one end of the resistor should connected over there, the other end of the resistor is connected to ground. So from these two terminals we are going to see the output waveform, and from these two terminals we are going to see the input waveform. Okay, so we have connected positive clipper circuit. Now we require to modify double-ended clipper. Just remove your CRO probe connections. Okay, and the resistor values are same, need not to change. Now take another diode take another diode. Okay, now so this is a positive terminal of the D1 should connect it to the other terminal, negative terminal. Okay, then the positive terminal of the D2 is connected to, so just I will just do a modification somewhere else here. I will take this point and connect it here. Okay, just connect it in parallel. Okay, in this fashion. Okay, so negative of D1 is connected to positive of D2, and positive of D1 is connected to negative of D2, and this is RS resistor and this is load resistor. Now the output of double-ended clipper, now CRO should be in a dual mode. Okay, and channel 1, so decrease the magnitude of the waveform and keep it in phi, and output also keep it in phi, and should be in DC mode. Output should be in a DC mode, and check it again. Keep both in ground. Okay, merge it properly in a ground, and open this and keep it in output in DC mode. Now check it out. For 0 V reference 1 and approximately equal to 0 V reference 2. For that, output is getting 0.7 at positive side clipper and 0.7 at the negative side clipping. Okay, now we will just give for V reference 1, let us say 1 volt. Okay, 1 volt, and adjust V reference 2 to 2 volts. And check it out the output waveform. See, now we cannot measure it properly. Just increase your channel 1 as well as channel 2 magnitude, and increase time scale also. Now measure it. So this is the ground position, positive side from here to here. So approximately 1, 2, 3, 4. 4 in the sense 0.8, 0.2, 0.4, 0.6, 0.8. 0.8 into 2. 0.8 into 2. So 0.8 into 2 is equal to 1.6. So actually the theoretical value is 1.7. So this is approximately equal to 1.7 volts at negative side. Again, so 1 unit. So use a Y position here. Bring it here. This clipped waveform. So 1 unit 1.2. So at a negative side 1.2 into 2 volts. 2 volts. So this is equal to 2.4. So theoretical value 2.7. This is approximately equal to 2.7. So this is a double-ended clipper waveform circuit. Okay. Then transfer characteristics. So just put it in XY mode and open this dual. So you will get like this, and keep the channel ground, keep both the channel in a ground, and use a Y position and use a X position and bring it to this dot into center of the CRO, and again open it. Now interchange your CRO probes. Now, so at the positive you will get approximately equal to 1.7. At the positive side you will get approximately equal to 1.7. At the negative side you will get approximately equal to 2.7. 2.7. Okay. So this is your double-ended clipper circuit.